Hello Year Sixes. We are very much looking forward to having you at Heathcote School in September. I hope you are all excited and ready to join us. My name's Mrs Hyde and I'm a maths teacher at Heathcote School, and I wanted to give you a little flavour of what a maths lesson might be like when you get to secondary school. So I've decided to do a little bit of a topic called probability, which you might not have come across that much in primary school, but it's something we do a lot more of when you get to secondary. And just to give you an idea of what kind of happens in a math classroom, obviously you're all very used to maths and I hope you're looking forward to doing some maths here. So, your title for today's lesson would be an introduction to probability, or is an introduction to probability. So we talk about the language of probability, and if we were sat in a classroom now, I would be asking you all for what you understand the word probability to mean. If you've heard of it before, do you have any ideas about what it means? Because it's one of those interesting things in maths that a lot of people actually already have a bit of an understanding about what probability means. So I'd be asking you all, we'd be having a bit of a class discussion about it. And then I'm hoping we could get to a definition, something like this. So I hope you can see this okay through the camera. But it says probability is a measurement of the chance or the likelihood of an event happening. So I've got some words in bold because they're kind of key words. So it's the chance or the likelihood of an event happening. And we'd be talking more about this and we'd be doing probability for a few weeks, but this would be a good place to start. And I imagine that when we were having our class discussion about what probability is, these are some of the words. Oh, sorry, I keep pressing the wrong mouse button. These are some of the words that some of you might have said to me. So you might have said, if something could be unlikely, there's a 50-50 chance. People say that that's something to do with probability. Something is likely, an event is likely. There's a poor chance, there's an evens chance, which is probably the same as 50-50. It's possible, it's probable, it's certain, it's impossible, it's very likely. So, think of what I got. There might be a few more. Yeah, I might go back onto this. No. So these are some of the words that you might have come up with when we were having our class discussion about probability. But these are all words that we use, that you will have used in your life so far, that are actually to do with probability. And probability can get quite mathematical, as we'll find out. Keep pressing the wrong mouse button. So, some mathematical vocabulary. In maths, we use the following words to describe the likelihood or the chance of something happening. So we say something is impossible. Now that doesn't mean, oh, it's impossible, that'll never happen. That means absolutely something that cannot and will not ever happen. No chance of it happening. If something's unlikely, then we think it might happen, but it probably won't. If something is likely, then it might happen and it probably will. And if something is certain, then that means it's definitely going to happen. And when we talk about particularly impossible and certain, because people know those words and they use them in their day-to-day lives, but when we talk about it mathematically, we mean not going to happen, not just something that you think might not happen. So not even like winning the lottery. Winning the lottery is an impossible. Right? So impossible means it cannot happen, and certain means it absolutely, definitely will. So we'll talk about some different examples. But this is a question I would have asked you. So it says there are 4 counters in a bag. 2 counters are red, 1 counter is blue, and 1 counter is green. Then the words are impossible, unlikely, even, likely, and certain. And the question says, which word from the box best describes the likelihood of each of these events? So you probably see from the way this is laid out, this is an old test question. So what is the likelihood that a counter which is taken at random is red? What is the probability a counter which is taken at random is yellow? And what is the probability a counter which is taken at random is green? I'm going to stop. And if you want to pause and have a think about those, then please do if you want to pause the video. But if we're saying a counter which is taken at random is red, well, 2 counters are red out of a total of 4 counters. So 2 out of my possible 4 chances are red. That means that there is an evens chance, because there's a 1 in 2 chance, there's a 50-50 chance of me getting a red counter, so we describe that as even. A counter which is taken at random is yellow. Well, we've got 2 red counters, 1 blue counter and 1 green counter. There are no yellow counters, So it's absolutely impossible for us to get a yellow counter from our options there. So what is the probability a counter taken at random is yellow is impossible. The next one, what word best describes the likelihood of a counter which is taken at random being green? Well, we've got 2 being red, 1 being blue and 1 being green. That means 1 out of the 4 options available are green. So it's possible, but I'd say it's quite unlikely. You've only got a 1 in 4 chance. If I had to pick one of these words, I'd describe that as unlikely. So well done if you got that right. Now, we also learn about the probability scale. So the probability scale gives us a way of visually representing the probability of something happening. So the chance of an event happening can be shown on a probability scale, which we draw like this with little lines to help guide us. And on the left-hand side, we put events that are impossible, that are never going to happen. On the right-hand side, we put events that are certain, that are absolutely definitely going to happen, and events in the middle are even. So in between even and certain, and in between even and impossible, hoping that you can start to be thinking about what words we could put in here to describe events that are in between impossible and evens, and in between evens and certain. I would describe an event in this section as unlikely. It's not impossible, it could happen, but it's less than an evens chance, so it's unlikely. And this side then, if it's more than an evens chance but less than certain, would describe that as likely. So the more you go this way along the scale, the more likely an event is. The more you come this way along the scale, the less likely the event is. So, some examples. So if we were in class again, we'd talk about, I'd ask you to come up with some ideas of some events that are impossible, unlikely, even, likely and certain. And we'd all have some good ones, I'm sure. But because you're not here with me yet, I have picked some events just to mark each part of the probability scale. So something that is impossible is you meeting King Henry VIII. You can't go back in time and meet King Henry VIII. That means that event is impossible. Something that is unlikely is you picking a day of the week and it's starting with a T. Because we have Tuesday and Thursday, but those are the only days of the week that start with a letter T, so that's unlikely. An evens chance is the next baby born being a boy, and another classic example with evens chance is flipping a coin and whether you're going to get heads or whether you're going to get tails. Likely, so likely that you would get homework this lesson. This is something that I would say if we were in class together, and I'd say it's very likely you're going to get homework this lesson, and then I'd give you some homework. But you're not going to get homework now because you're not in school yet. And something that is certain is a square having 4 right angles. A square, all squares by definition have 4 right angles, so that means that that statement is certain. So, that's the probability scale, but sometimes words alone aren't enough. And in our maths classrooms, we always think of ourselves as mathematicians. So as mathematicians, how can we be even more accurate when we're talking about probability? Well, probability can be expressed as a number, and that allows us to be even more accurate, which is why it comes into maths. So, we always measure probability on a scale of 0 to 1, and we can put that information onto our probability scale that we just made and would have discussed if you were in school. We say that if an event is impossible and has no probability of occurring, then it has a probability of 0. And we say if an event is certain, then it has a probability of 1. So we can transpose that onto our probability scale. So before we had 0 being impossible, 1 being certain, the left-hand side being impossible and the right-hand side being certain. Well, now we put a number to that. So we've got impossible being 0, certain being 1. And an evens chance being this half point, halfway in the middle between 0 and 1. Now, probabilities are written as fractions, decimals, and less often, but sometimes, as percentages. Now, depending on what you're used to doing in primary school and what class you're in, we would have covered some work, definitely, on converting between fractions and decimals and percentages. So I'm hoping that some of you will already be familiar with that, but if not, you certainly will be by the time we get to the end of year 7, because we'll do some work on that together. But the probability that an event will happen is always a number between 0 and 1. If it's lower than 0 and if it's a negative number, we've gone wrong. If it's higher than 1, we've also gone wrong. It's always a number in between them. Certain equals 1, impossible equals 0, and we know probability can be expressed as a fraction, a decimal, or a percentage. So we could say there's a 1 in 10 probability of something happening. You've got 1 in 10 chance of something happening. As that fraction, some of you might already know, if I wanted to represent that fraction as a decimal, it would be 0.1. We remember that this 1 is the tenths column of our place value. So it's 1 over 10 and 0.1. These mean the same thing as each other. One's a fraction, one's a decimal. And then if I wanted to put this as a percentage, some of you might know already, is 10%. If you said 1%, that's a classic mistake that people make, but this is the tenths column, so that's 10%. So we said probability can be expressed as a fraction, a decimal, or a percentage. And if you wanted to, you could change between them, right? With your mathematical ability, you could change it between a fraction and a decimal and a percentage. But the question often tells you what form you're going to be working in. So, 4 jelly babies are in a bag, 2 are red, 1 is green and 1 is black. Without looking in the bag, a jelly baby is taken out, and then if we were in class, I'd ask you to draw out these 3 probability scales, or I'd have them printed out for you, and I'd ask you to put a cross on the scale with where these events would happen. So, if you want to have a go at these, pause it now, and I'll go through them in a second. But this first one on a probability scale, mark with a cross the probability that a jelly baby taken from the bag is green. So this is the same as what we were discussing earlier, now it's not on a probability scale with words, it's just on a probability scale with numbers. So what's the probability that the jelly baby taken from the bag is green? Well, there's 1 green, I haven't got a whiteboard pen, there's 1 green out of the 4 options. So that's 1 over 4, which is a quarter. So I'm hoping that some of you would have put your cross here, halfway between 0 and a half, because there's a 1 in 4 chance of you getting the green jelly baby. The next one on a probability scale, mark with across the probability that the jelly baby taken from the bag is green or black. Well, there's 1 green and there's 1 black. That means there's 2 options in that bag out of the 4 in total. So 2 over 4 is half. It's the same, right? 2 quarters can simplify to a half, which means that you should have your second cross right in the middle there. There's an evens chance. And the last one on the probability scale below, mark with a cross the probability that the jelly baby taken from the bag is red or black. So red, there's 2. Black, there's 1. That means now we've got 3 options out of a total of 4 of successfully getting what we wanted, because what we want is a red or a black. So now we've got 3 over 4, which is the same as saying 3 quarters, which I'm hoping some of you will have put there, right, 3 quarters, halfway between half and 1. Now, if any of you have done that at home and you've got any of those right, really well done, because we've covered a lot of material so far. Now I'm just going to do a little bit more, which is about calculating probability. So, if the outcomes of an event are equally likely, then we can calculate the probability using this formula. The probability of an event is the number of successful outcomes divided by the total number of possible outcomes. So if you want to write that down to help you remember it, in class I would encourage you to write it down to help you remember it. Number of successful outcomes over the total number of possible outcomes. And remember, it's perfectly acceptable to give your answer to a probability question as a fraction, so you can just leave your answer like that and it will become clear when I go through some examples in a minute. For example, this bag contains 1 yellow, 3 green, 4 blue, 4 blue and 2 red marbles. And the question says, what is the probability of pulling a green marble from the bag without looking? Well, we want the number of successful outcomes, which is 1, 2, 3, because we want green, over the total number of possible outcomes. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 balls in the bag in total, 3 of which give us a successful outcome, so my probability is going to be 3 over 10. That's perfectly acceptable to leave my probability like that, but I could write that as 0.3. 3/10 is the same as 0.3. And if I wanted to, I could also write that as a percentage, which would be 30%, which means that you've got a 30% chance of getting a green marble when you pull it out of the bag in this situation. So I'm hoping that makes sense. So, this spinner has 8 equal divisions. What is the probability of the spinner landing on a red sector, a blue sector and a green sector? So if we were in class, we'd talk about this together and I'd get you to help me answer these questions. So if it was a red sector, there are 2 successful, well, there's 2 options on our spinner that satisfy it being a red sector. Out of 8 equal divisions. There's 1, 2, 3, 4, 5, 6, 7, 8 divisions on the spinner, 2 of which are red. That means the probability of getting a red spinner is 2 out of 8. The probability of getting a blue sector, well, there's only 1 now out of my 8 in total, which means the probability of getting a blue is 1 over 8. The probability of getting a green, I'm hoping that you can all see, there are, unless that's a weird shade of green, I think that's yellow, there are no green sectors on my spinner. Oh no, that is a green. Sorry, that looks yellow in my camera. So that means there are 1, 2, 3, 4 green options out of our total of 8. So the probability of getting a green is 4 over 8. Notice, some of you will have already noticed that I haven't simplified these fractions. And probability is the one time in maths where we do not have to simplify our fractions. Right, I've been talking for ages, so I'm just going to do a little bit more. What I would do now in class, if we were together, that some of you might have experienced in primary school, is called whiteboard work, mini whiteboard work. So we do this a lot in maths. So this would be a good example of a mini whiteboard question. So in our maths classroom, you have mini whiteboards on your desk, and this question says, find the probability of choosing a yellow sun. And then you would all, as a class, have to write your answer, what you think your answer is, down on the mini whiteboard, and then hold it up for me to check. So this one, there are 2 yellow suns out of 1, 2, 3, 4, 5, 6, 7. So I would write 2 out of 7, and you'd hold it up to me, and I'd say, yes, you got it right, well done. So I'm going to do this one's 2 out of 7. I'd like you to have an imaginary mini whiteboard, but just write down on a piece of paper or think in your head what the answer to this one is. Find the probability of choosing a moon. And I'm hoping that some of you will have got this 1, 2, 3, 4, 5 moons out of a total of 7 shapes. So we've got 5 over 7. Now, find the probability of choosing a green moon. And we've got 1 out of 1, 2, 3, 4, 5, 6, 7. So I'm hoping that some of you have written down 1 over 7. I'll give you a little bit more time than that in the classroom. Now find the probability of picking red. Well, we've got 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7 in total. So the probability is 3 over 7. What's the probability of picking blue? Is 1, 2, 3, 4 over the 7 in total. Some of you will have noticed, or might be starting to notice, that these two, because they're all of the options, will add up to 1. Let's do one more. So find the probability of picking green. Should have got 1, 2, 3, 4, 5 out of a total of 8. The probability of picking orange is 3 over 8. And then I will leave you with this. So this is, once we have done some work together as a class and had some discussion, and you've helped me do some, and then say we did some mini whiteboard work, I then want you to do some questions in your book by yourself, so I could make sure that you know that you definitely know how to do it. So if you want to pause the video and have a go at these, there's 2 questions, so there's a part A and a part B, and question 2 has got A, B and C. So pause it now and have a go. And then the answers are on the board. And then you would, in a maths classroom, you would be marking your work with a green pen that you must always have with you. You'd mark your work, any you've made mistakes on, you'd ask me and I'd help you figure it out. But I hope that is a good little introduction. Just that's a lot of information in 20 minutes, so a lesson would obviously be much longer than that. We'd have much more time to have more discussion. But that's a little introduction to probability in secondary school, and I look forward to seeing you here in September, hopefully. Hope you have a very nice summer.